All right, welcome to this video on scientific notation. Scientific notation helps us express really large numbers and really small numbers simply so that we can do some calculations and computations. So the first thing we're going to do is we're going to type these two numbers into our calculators, a little warm up, and see how our calculator deals with it and just kind of see what we notice. So the first one is 1 over 2,100. So I'm going to open my calculator. And we're going to take 1 over 2,100. And what you notice here is it gives us something very different. It doesn't give us just a decimal, but it gives us a decimal times 10 to the negative fourth. And that we're going to talk about here in this unit and this lesson. And what that is, that's a way that we can express a very small number is with what are called negative exponents. And that's where instead of multiplying by 10 four times, we're going to divide by 10 four times. And that would give us that answer. So the other one, we're going to go ahead and flip back. So that equals 4.76. 4.76 times 10 to the negative fourth power. And then we're going to look at 4 to the 23rd power, which is going to give us a very large number. So 4 to the 23rd power gives us 7.04 times 10 to the 13th. So 7.04 times 10 to the 13th power. So what we have there is we have 7.04 times 10, 13 times. And that is a very large number. But this, the way it's written here, we can deal with it. We can add it, we can subtract it. Multiply and divide. This is how scientists, scientific notation, like to deal with really large numbers and really small numbers. Because sometimes scientists are dealing with the distance from the Earth to the sun, which is a very large number. Or they're dealing with very small numbers, like the width of a human hair. Okay, and so scientists developed a way to deal with very big numbers and very large numbers. It's called scientific notation, and it is always written in the format a times 10 to the nth. A must be between 1 and 10. Has to be at least 1, but no more than 10. And then n is a positive or negative integer. So it could be negative 7, it could be positive 7, or anywhere in between. So as we look at example 1 here, we're going to look at for which numbers are in scientific notation. So the first number is not in scientific notation. And the reason why it is not in scientific notation is because of right here, 11.6. 11.6 is larger than 10, so it is not in scientific notation. The second one is in scientific notation. 2.4 is between 1 and 10, and then we have times 10 to a number power of 6. That works. The second one is not in scientific notation, and the reason why it's not in scientific notation is that 7. Scientific notation must be 10 to the n. The next option, perfect scientific notation. The third option, not scientific notation again, because we don't have a 10 as the base of our multiplier. So this here is the issue right here, that 5. All right, now, scientific notation, it's important to know where the decimal place is. So we call it an invisible decimal. I want to remind you, it occurs after here, here, and here. Because when we talk about scientific notation, we are going to be moving the decimal place. And that multiplying by 10 moves the decimal place to the left. Dividing by 10 will move it to the opposite direction. So if the number is greater than 1, the exponent will be positive. Okay? If the exponent is less than 1, the exponent will be negative. And then the exponent will tell you how many times to move the decimal place. All right, let's look at converting what's called standard form, or just a normal number, into scientific notation. So what I notice here is I notice a large numbers in A and B and very small numbers in C and D. So I know that A and B are going to have positive exponents, and C and D are going to have negative exponents. So what we need to do is we need to look for the numbers starting with the first number we see. So those three numbers are going to become our first part of our scientific notation, our A. And then we're going to figure out how many times we have to move that decimal place. So we're going to move it 3, 6, 9, 12 times to move it right there. So our number is going to become 9.123 times 10 to the 12th power. And those numbers are equal. So if I go and I type those into my calculator, they will both return the same thing. Now, the second one is a little simpler. We have to move the decimal place fewer times. We only have two numbers there, so we're going to write that down as 3.70 because I want my decimal place to end there. And then we're going to count how many times does it take to move our decimal place from its starting location there to its ending location. So starting to ending. So let's go ahead and count 3, 4, 5 times. So we're going to have 3.70 times 10 to the 5th power. You could write this as 3.7 times 10 to the 5th. That would work as well. I should have mentioned on the first one, this 3 is unnecessary. You could leave this as 9.12. All right, now the next ones. We have very, 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 very small numbers. So we got to count how many times do we want to move the decimal place. And we have to move the decimal place to what makes these three numbers between 1 and 10. So where I have to put that is right between the 5 and the 4. So what I'll get is I'll get 5.47 times 10. Now I got to count the powers. So I got to see how many times we move the decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Now, since it's been smaller, what I've really done is I've taken the 10.47 and not multiplied by 10 9 times. I've divided by 10 9 times. And how we represent that is with a negative exponent. Next one's a little simpler. Again, we want to get 7.6. So we're going to have 7.6. We want that decimal place to land there. We must move it once, twice, 3 times. So 7.6 times 10 to the negative 3rd. All right, so that's converting to scientific notation where we count how many times we need to move the decimal place. Example 4 onto the back, this references how many times, this is going to be writing it in standard form. So we're actually going to go ahead and move the decimal place this time. So the first step is just to write out the numbers you see. So I'm going to write out 1.1257. Now I'm not going to put a decimal place, but what I'm going to do is I'm going to move the decimal place 8 times. So I'm going to start with it here between the 1 and the 2 as you see it, and then I'm going to move it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So now, for every one of these spaces that I moved it, I'm going to need to add a 0 because we're multiplying by 10. So we're going to add 1, 2, 3, 4, 5 zeros. We don't add 8 zeros. We add 5 zeros because that's how many times we had to move the decimal place past that 7. So what we have here is we have 1, 2, 5, 7, and then 5 zeros. So if we were to talk about what this number actually is, we have 125,700,000. So that's the answer to that one. This next one, we write the 3 down. The decimal place is right there. We're going to move it 4 times. 1, 2, 3, 4. We're going to place a 0 in each one of those spots. So we have a 3 followed by 4 zeros. That number would be 30,000. All right, so now here on C, we are going to go ahead and we're going to write down 3.25. But now we're going to move the decimal place to the left because we're making the number smaller. So we're going to move it 6 times. 1, 2, 3, 4, 5, 6. That's where my new decimal place is. Fill in with zeros. So the number we got is 0.0000325. A very, very small number. All right, let's do the next one. We're going to write down 9.8. We are going to move it to the left twice. 1, 2. So we end up with 0.098. All right, let's talk comparing. Now, it's very, very easy to compare when you have 10 to the 4th. Okay, on both of those. So 4.5 times 10 to the 4th and 1.5 times 10 to the 4th. Well, 4.5 has to be bigger because very simply, 4.5 is bigger than 1.5. Now, here, this one's really easy to compare as well because the 4.5s are the same. Well, I've got 4.5 times 10 to the 7th. 10 to the 7th, very large number. 4.5 times 10 to the 2nd is 100, not as large. Oop, got an alarm going off. So this would be greater than. Now, these two. This one's a little weird to think about. 7.6 is smaller than 8.1, so it would be less than because they have the same value here of negative 12. This one, even though, so 9.3 and 9.3, negative 15 and negative 13 is smaller, so it would look like that. All right. In a couple of weeks, we're going to do a lot more conversation about how to do computations, meaning addition, subtraction, multiplication, and division in your graphing calculator or in your calculators and by hand. Today, I'm just going to show you how to do it. I'm going to show you how to do it in a calculator. So we have 5.6 times 10 to the negative 6 times 3.5 times 10 to the 15th. So this is very easy to do in a calculator. We're just going to go over to a calculator. We're going to type in exactly what we see. So we're going to type in 5.6 x 10. Now notice how I use an x to represent multiplication. Here the computer is going to use the dot. And then we're going to multiply this entire thing. We should really put this in parentheses. Times 3.5 times, and I'll put this in parentheses as well, times 10 to the 15th power. All right, so this ends up giving us an answer in scientific notation because it needs to be in scientific notation. Anything with more than 7, 8, 9 numbers after the first number is going to give us an answer in the calculator in scientific notation. So our answer here is 1.96 times 10 to the 10th. Very large number. So we're going to end up with, we're going to write down 1.96 as we go to transition this. We're going to move it once, twice, and then we have to keep going. 3, 4, 5, 6, 7, 8, 9, 10. We're going to put a 0 after each one of those. So we have 196 and then 8 zeros. So if I put in my commas, which by the way you cannot do in Desmos, Desmos will not take commas. Okay, what we end up with is these are the hundreds, thousands, millions, billions. So what we have is we have 19,600,000,000. Very, very, very large number. All right, let's do some division here. 6 times 10 to the 12th divided by 2 times 10 to the 3rd. So what we have to do here is we've got to give ourselves a fraction first. The fraction is over there under the wrench, the a over b. So we're going to have 6 times 10 to the 12th over 2 times 10 to the 3rd. And this will end up giving us 3 times 10 to the 9th. So 3 times 10 to the 9th. So if I go ahead and write that in standard form, 3, there's my decimal place, move it 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3 and then 9 zeros. So 9 zeros, that would be 3 billion. All right, thank you for listening, thinking, writing, and following along. Please come ask me if you have any questions.